So our focus for this week is going to be about portfolio theory, and we are going to be looking at a rather complicated set of problems where we are thinking about portfolio theory where the underlying assets are different risky assets. But before we get into that, let us briefly review what we discussed last week by looking at a much simpler problem compared to what we solved last week. So imagine that you have a choice between two assets. So you have got 100 units of money to invest, and your options are either you're going to invest it in asset X or in asset Y. And unlike last week, where we discussed about how do you decide about how much of the money to put in asset X versus how much of the money to put in asset Y, we are going to think about these choice problem as only a choice between putting all of your money in asset X versus putting all of your money in asset Y. So which one should you do? Well, that depends on the characteristics of the assets, okay, as well as your preference profile, right? So let's look at both aspects. So what do we know about the assets? So asset X is going to pay off 105 with certainty if you invest 100 units of money in it, okay? So this is basically a risk-free asset because you know for sure how much you are going to get if you put money here. Asset Y, on the other hand, is a risky asset in the sense that you don't know for sure how much money you are going to get if you put in money here. So if you invest 100 units of money in asset Y, it's either going to pay off 120, which will happen with probability 0.8, or it will pay off 90, which will happen with probability 0.2. So these are the two characteristics of the assets that we have. And on the basis of this, what do we know about the expected rate of return and the standard deviations, right? So that would be the next question to ask. So what's the rate of return on X? Well, it's 105 minus 100 divided by 100, so 5%. And the standard deviation of return of X on X is 0, right? Why is it 0? Because it's going to pay 105 with certainty, right? So 5% with certainty. There's no uncertainty about how much you are going to get from here. What about asset Y? So we can calculate what's the expected rate of return on Y. So it's the weighted average of the two rates of return. So in this state where it pays off 120, the rate of return is 20%. And in the state in which it pays off 90, the rate of return is negative 10%, right? So we'll weigh these rates of return with the probability of these occurring. So therefore, the expected rate of return on Y is 0.8 times 0.2 plus 0.2 into minus 0.1. Again, 0.8 and 0.2 are the probabilities, and 0.2 and minus 0.1 are the rates of return in the two different states. So if we go ahead and do the calculation, we can see that this is equal to 0.14. We can also similarly calculate the standard deviation of the rate of return. So again, this is the square root of the weighted average of the deviation from the mean. So 0.8 is the probability of this 0.2 rate of return happening. And then the mean we calculated is 0.14. So 0.2 minus 0.14 times square plus 0.2 into minus 0.1 minus 0.014 square, right? And we have to take the square root in order to get the standard deviation. And we end up getting that this is equal to 0.12. Okay, so these are the characteristics of the two different assets. Which one would you prefer? Well, the answer is clearly going to depend on preferences, right? So for example, if you had somebody who was risk neutral, which means that that person only cares about the expected rate of return of the different options, then the answer is clear, right? So the expected rate of return on X is 0.05 and the expected rate of return on Y is 0.14. So clearly a risk neutral person would choose Y. But if you are somebody who dislikes risk, maybe your answer would be different, right? Why would that be the case? So if you notice, even though you have got that Y is giving a higher expected return compared to X, clearly we observe that there is some risk involved in Y, right? And if you dislike risk enough, maybe your answers might switch, right? So you might end up preferring X over Y, right? So in order to think about questions like this, that's why we looked at a class of preferences called mean variance preferences. So this is probably the simplest structure to look at the preference of somebody who might dislike risk, right? So when we say that somebody has mean variance preferences, what we mean is that that person only looks at the expected return and the standard deviation of different alternatives to rank those alternatives. And we can represent these preferences via utility functions or indifference curves as usual. So let's look at both of these things. So this is an example of a utility function which represents mean variance preferences. So utility from an alternative is equal to the expected rate of return minus half times a, which is a constant, which we'll talk about, times sigma square, where sigma square is basically the variance of the rate of return, right? So note that this expected return and sigma are both actually expressed in decimals. So if you have got, let's say, 5%, then this expected return is 0.05, right? And similarly, if sigma is, let's say, 10%, then sigma is actually 0.1. Okay. What about this parameter A? Well, that is a parameter that basically measures risk attitude. So let's think about the different cases. Suppose that first you have got A equal to 0, then this whole term related to sigma square drops out, and then your utility is just the expected return, right? So then in that case, you only care about how much on average return that you are getting, and therefore this is a sign of a risk neutral person, right? Remember, who evaluates things as per the expected value. Then you have got a case where if A is strictly greater than 0, then this is a person who dislikes risk, right? So here, if you observe that if A becomes greater than 0, then higher the risk associated with a choice, the more the person dislikes that choice, right? This is the case that we had focused on last time. And the other thing to notice is that higher the value of A, this is going to correspond to a person being even more risk averse, right? In the sense that higher value of A corresponds to this person disliking risk even more. We could have actually also thought about risk lower in this framework as well. So in that case, we would have needed to A to be less than 0, in which case the person actually ends up liking the risk because you have got minus half A. So therefore, if A is negative, then this becomes a positive function of the sigma square, right? So more risk, the better off this person is if A is negative, right? But we are not going to be focusing on that case. Our most of our focus is going to be on this case where we have a risk averse person. Okay, so let's use this person. Suppose that a person has preferences given by this utility function, and suppose that A equal to 2, right? So that means that this person is a risk averse person. Now, suppose that this person has a choice between X and Y, the two assets that we discussed before. What would she prefer? So in order to answer this, we need to look at what's the utility that this person gets from X versus what's the utility that this person gets from Y. So remember that in X, we had that the expected rate of return is 5% and the standard deviation is 0. So if we now plug in this information, expected return equal to 5 and sigma equal to 0. So therefore, expected return is 5%, so 0.05, right? So then we end up getting that U of X is 0.05 for this person. What about for Y? We have got that the expected rate of return is 0.14 and the standard deviation is 0.12. So we can again plug in this. So half A, by the way, will become 1. So therefore, you end up getting 0.14 minus 0.12 square. And if you do the calculation, you end up 0.1256, right? So clearly that is more than 0.05. And therefore, this person will also prefer Y, right? So it's not the case that if you have a risk averse person, then that person always is going to go for the less risky option, right? If the expected returns are high enough from the safe option, then that person might actually go for the less risky option, but that's not guaranteed, right? So for example, here, the expected return was not high enough from the risk-free option, and hence the person ended up still going for the riskier option, which involved uncertainty, even though this person dislikes risk. So what are the things that would convince this person to switch to the risk-free option, which was X here? Well, two things, right? One is that either the asset X becomes more attractive in the sense that it starts offering a higher rate of return, right? And alternatively, the person becomes more risk averse in the sense that this person's A goes up, right? So if the person really, really strongly dislikes risk, then even a little bit of risk might be something that is not preferred by this person, right? So that's what we are going to do at the next two exercises. How high should the value of the rate of return from X be in order for this person to switch? Alternatively, how high should the value of A be so that this person actually, even with this numbers, would prefer to actually go with choice X over choice Y. So the first question is, what should be the rate of return for X in order for this person to prefer X over Y? So suppose that the rate of return for X is Rx, then the utility of X is going to be based on this utility function is just going to be Rx, right? Why is that? Because remember, sigma equal to 0 for choice X. And so therefore utility is always equal to expected return when it comes to choice X. And so therefore utility is Rx, right? What about the utility from Y? Well, that's still going to be the same as we had here. Nothing is changing with respect to Y. And so therefore you get that the utility of Y is 0.1256, right? So from here, we can see that if we want this person to select X over Y, we need Rx to be more than 0.1256, right? So we want Rx to be greater than 12.56%, right? This is just 5%. So clearly this is not enough. We need it to be much more, right? So that's one way in which we can make the person switch to X instead of Y. And the other way in which we can do it is that we can actually have a higher value of A, right? So let's go back to the original choice. Remember that X was giving 105 with certainty if you had put in 100 in X, and Y was giving you 120 with probability 0.8 and 90 with probability 0.2. But now what we are doing is that we are changing the value of A, right? So we are saying, let's allow the value of A to be whatever you want. We want to find out what's the value of A for which this person is going to be indifferent between X and Y. So we need to evaluate the utility of these two different choices as a function of A, right? Now, if you think about it, this was the utility function that we had, but now we are not putting in A equal to 2. What happens if you are choosing X? Well, in that case, sigma is 0, right? Because you're getting this 105 with certainty, but this expected return is 0.05, right? So then we are going to get that U of X is 0.05. What about utility from Y? Well, the expected rate of return was 14%, right? So then if we go back here, we are going to have this as 0.14, and the sigma we had calculated as 0.12. But now instead of putting in A equal to 2, what we want to have is that we want to write this as half A, right? So if we put in all this information, we end up getting that U of Y is 0.14 minus half of A, 1/2 square, right? And we want A to be such that the person is indifferent between X and Y, so that the utility of X and utility of Y are the same. So if we want to equate these two, and if we go ahead and do that, we see that we'll end up getting a value of A is equal to 12.5. So that tells us that if A was equal to 12.5, this is a person who is quite risk averse, then this person would have been indifferent between the two choices, given the different yields that are given, right? However, if the person had a value of A being greater than 12.5, then this person would have preferred X, right? In that case, this U of X would become larger than U of Y. So that's one way of ranking preferences utility functions. The other way is to think about indifference curves. And here we see on the plane that we had seen before, expected return and standard deviation, how indifference curves would look like. So here, the blue curves correspond to risk aversion parameter A equal to 2. And the orange curves correspond to risk aversion parameter A equal to 10. So obviously that is going to be more risk averse. And we can see that here as well, right? So for example, suppose that you start out at 10%, and then if you increase the standard deviation a little bit, we see that the person who is more risk averse would need a higher compensation in the sense of higher expected return in order to be still indifferent as the original choice compared to somebody who had a lower risk aversion, right? So that's one thing to note about the differences. And of course, as usual, risk aversion indifference curve maps gives you a lot of information. So for example, you do know that for the same standard deviation, the higher the expected return you are getting, the better off you are. So therefore, as we had discussed last week, the indifference curves better basically maps us as that you are better off the more to the northwest you are moving, right? Because that would correspond to lower standard deviation and higher expected return. So these are just kind of a review of what we discussed last time. And now we are going to move on to consider new set of choices, namely choices among assets where all the assets are risky. So that we can basically extend our notion of portfolio optimization problem.